And then my, if I were to use right-hand rule, this will be compression, and this will be tensile. So from here, again, I will have our points. Okay, A, B, E, D. And then again, we have our my and mz. Okay, and on point A, my is compression. Point B, my is in tension induced by my. And point E is in compression. Point D is in tensile. And then we're going to look at mz at point A and point B. Both will be in tension, right? And point E and point D due to mz, both are in compression. So this will be maximum tensile. This will be maximum compression. So based on the orientation, so we know that this is the green that I've drawn. This is our neutral axis. Now we know that anything that is down here, okay, by looking at point E, is going to be compression. Anything that's above it will be tensile. Okay. So you can see, like what I told you guys before, there will be a flip. Okay. So in the exam, I'm not saying that this question or term test, I'm not saying that this question will come out. But if it does, okay, you have to know, you have to just think about this diagram. Okay. And then from this diagram, you can able to derive out the equation to relate the neutral axis, okay, to or determine the angle of the neutral axis. And I think the most important thing what you see today is this arrow over here, what to do when it has gone in the opposite direction. Okay. Any questions so far? Are you okay? Anything that you all want me to clarify? Okay, I don't hear anything. So any question regarding bending moment? I'm not saying that this is the most difficult one, or I'm saying that I don't think the homework have enough example on this. Okay, so that's why I'm doing this to clarify any doubt from your end. Okay. Anyone, any other question regarding bending moment? Can be anything from the homework. Anyone? I don't hear anything. Okay. If that's the case, I would like to move on to shearing stress. Okay. I know this week I just posted some questions on Tuesday. Probably some of you who are taking 2 courses now don't have the time. So I will do some question on shearing stress based on homework number 4. Okay, so let's look at, I don't know homework number 4 is, wait, let me pick one that is interesting. This one is too boring for you. I think I've seen one that I think will be really good for you. Hold on. Probably is in homework 3. Okay, I want to pick on this question, and I'm going to do something more. Okay, and I want you to I think I show you how to form the equation, but I want to like show you how to do it again. Okay, just to revise. Oh, sorry. So in shearing stress, okay, in shearing stress, what is the most important are the rules that I wrote for you. Okay, and I hope before the term test you will remember the rules. Oh, wait, my bad. So I want you to see my camera down here, and I have nothing to look at. Okay, it's just my notepad and you. Okay, I have nothing to refer to. Usually when I'm writing on notes, I have something to write on. Now I have nothing. It's just my calculator. Okay, so I'm going to write out the rules. I will try to remember the rules when we do shear stress. Okay, so I know number one, V and I, or V and I are constant. Okay. Number two, datum is at centroid, right? And then number three, analysis direction starts furthest away from centroid. And then number four is first moment of area. Okay. Or I just write Q cannot cross the centroid. Okay. And I remember we wrote number five, Q is in one direction only. Okay. So once you have these five rules, things will be straightforward. Okay. So we are asked to determine the maximum shearing stress. Okay. So for a problem like this, again, we drop your transformation. This will be your X. This will be your Y. And then we have our Z. Okay. So we know that we have Vy. Okay. So we only have V. So the shear stress is equal to Vy over Izz, okay, Qz divided by T. Okay. So immediately we need to find, we know that Vy given, Vy is equal to 12 times 10 to the power 3 pound force. Okay, this is given. So from here, I'm just going to sketch the cross section. Okay. And yep. So we have 4, 8, 12, and 3. Okay. And then we have 6 and 4. And we have 2, 4, 6, and we have 4. Okay. So we are going to find the centroid. Okay. So I hope you will use this method that I have devised, or I've taught you guys. Okay. So the axis of interest is our z-axis. So I don't know exactly where our centroid is, but I'm going to sketch. So for this case, it's not so obvious that you can find your centroid based on observation. We don't know yet. Okay. So this is our ZZ, and this is our so-called centroid. And we know we want to find IZZ. We know that this is our width. And over here, this is our depth. Okay, or sorry, not there, but this orientation over here, because it's 90 degrees, this is our depth. Okay, so from here, we're going to find our centroid, right? So we divide into section. And I strongly recommend you use this technique because you will make less mistake. Then you have your flange, and then you have your web. Okay, and then we will have your width, depth is equal to area. So this is what we call our flange, and this is what we call our depth. Okay, so the width by looking at the diagram is 12. The depth is 3, right? And then for the web, the width is 4, the depth is 6. Okay, so then this will be equal to 12 times 3 is 36. 6 times 4 is 24. Okay, then it's up to you where you want to take your datum, okay, for your y bar. So I'm going to take my y bar from the top. So this is what I mean, the datum from the top. Okay, so this is 3 divided by 2, it's 1.5. This is 3 plus by 6 divided by 2, which is equal to 6. Let me, yep, 3 divided by 2 is 1.5. 3 plus by 6 divided by 2 is 6. Okay, then the next column is where we have our A, Y top. Okay, so 36 times 1.5 is equal to 54. Okay, so 12 times 3 times by 1.5 is 54. 4 times 6 times 6 is equal to 144. Okay, so 36 plus 24 is equal to 60. 144 plus by 54 is equal to 198. So the y bar is equal to 198 over 60. It's equal to 3.3 inches from top. Now you can check your value whether is it right or wrong. And how do you check? What I usually do if doing exam you have time, I will do the y from bottom and see what happened. Okay, so y from bottom, this will be 6 divided by 2 is equal to 3, and 6 plus by 3 divided by 2. Okay, so what we are doing now is we are taking the datum from the bottom. Okay, and if it's right, okay, if it's right, this value, wait, I'll show you what will happen if it's right. Let's calculate first. Okay, so 6 plus by 3 divided by 2 is equal to 7.5. So your numbers are slightly different over here, which is valid, right? Then you have your A, y bar bottom. We started from the top, now we are doing bottom. So it's 36 times by 7.5 is 270. And then 24 times 3, 72. Okay. And then you add together 270 plus by 72 is equal to 342. So y bar from bottom is 342 divided by 60. Okay. So 342 divided by 60 is 5.7. from bottom. So how do we know this is right? Because if you take 3.3 plus by 5.7, right? 3.3 plus by 5.7 is equal to 9 inches, right? And we know this entire thickness over here is 9 inches. Okay, so that's how what I tend to do when I check. Okay, just a small trick for you. If the numbers don't come out to 9 inches, there is something wrong. Okay, there is something wrong with the calculation. So these are things that could help you check. Okay, what I propose now is we go for a short 5 minutes break and we come back again.